Alright, so in this lesson we're going to talk about Dalton's law and Graham's laws and how they relate to gases. So the total pressure in a mixture of gases is equal to the sum of the pressure of all the gases in the mixture. This is Dalton's law of partial pressure. And the formula, which you can find in your reference packet, tells us that the total pressure is equal to the pressure of the sum of gases. And so however many gases you have, you would just add them all together, and that gives you the total. So let's look at this problem here. What's the total pressure of a container of air if the gas has a partial pressure listed below? So if we have oxygen has a partial pressure of 2, nitrogen is 11, carbon dioxide is 1, and then there are other gases that are 1, what would be the total pressure? So again, our P total is the pressure of the oxygen plus the pressure of the nitrogen, plus the pressure of the carbon dioxide, plus the pressure of all the other gases, and so we get that the total pressure is 2 plus 11 plus 1 plus 1, right? And so we get 11, 12, 13, 14, 15 atmospheres. Now the thing you have to keep in mind here is that in order to add them together, your units of pressure must all be the same. So if these had different units of pressure, we would need to convert them. That's Dalton's law. Pretty simple. Graham's law talks about the diffusion of gases. So what does this term diffusion mean? You've probably all heard of diffusers, right? You may even have some in your house, right? It makes your house smell good, right? And so diffusion, right, is basically the motion of particles, right? The movement of these gas molecules, right? So, and that is from a high concentration to a low concentration. So diffusion is the movement of gas particles from high concentration to low concentration. You know, think about air freshener or perfume. When you spray it really close to you, you smell it very well, right? That's high concentration. And so then eventually it starts to spread apart. And that spreading apart is called diffusion. And as it spreads apart, right, and it travels, then more people can smell it, right? And eventually it'll spread apart so far that then people wouldn't be able to tell the smell. Effusion is the escaping of gas particles through a small hole. So think about your helium balloons, right? You get these balloons for your birthday, they last for a couple of days, then that balloon starts to sink, and eventually it's on the ground, right? And it's deflating. But you didn't deflate the balloon, you didn't pop at it or anything. But the reason why it's deflating is because those helium atoms are escaping through the small holes that are in the latex or the plastic that's the balloon, right? And so those holes, though, are really tiny. We can't see them with our naked eye. But also, helium atoms are the smallest atom of all, right? And so they're really tiny too, and so they can escape through those particles, through those holes. Okay, so the rate of diffusion and effusion is proportional to the molar mass of the gas. So let's think about how they're proportional. So they directly or inversely proportional. So we want to think about, do things that have large mass move slowly or do they move quickly? Right? So things that have bigger mass tend to move more slowly, right? And so if we have a big mass, then you're going to move at a slower rate, right? And so that makes them inversely proportional. Okay? So let's think about ordering these from the highest rate of diffusion to the lowest. That means we need the molar mass of each. So hydrogen is H2, so it has a mass of 2.016. And then ammonia is NH3, which has